What is differentiation? Differentiation is a process in calculus used to find the rate at which something changes. It tells you the slope or steepness of a curve at any point. For example, if fx equal to x squared, then the derivative f prime x equal to 2x tell how fast x squared is changing.
What are the techniques of derivative in calculus? Differentiation is a key concept in calculus that helps us determine how a function changes with respect to its variable. To find the derivative of a function, several techniques are used depending on the form of equation. The power rule is the most common method. We state that the derivative of is nx power of n is nx power of n minus 1. When function involves constant, the constant rule and constant multiply rule allow us to derivative them easily. For expression made of several terms, the sum and the different rules let the derivative is termed separately. When two functions are multiplied or divided, we use the product rule and quotient rule. We give formula for derivative distribution. The chain rule is applied when one function is inside another, helping a derivative composite function. In situations where y and x are measured together in an equation, implied differentiation is used. For more complex expressions, especially those involve product, power, or variable in both the base and exponent, logarithm differentiation simplify the process.
For question 1a, y equal to square root 2x minus 1 sine 3 minus x. Here we have a product of two functions, the square root of 2x minus 1 and sine 3 minus x. So we will need to use the product rule. Using the chain rule, the derivative of square root 2x minus 1 is 1 over square root 2x minus 1. Next, the derivative of sine 3 minus x. Again, using the chain rule, the derivative of sine 3 minus x is negative cosine 3 minus x. Now we apply the product rule. We say the derivative of the first time the second plus the first time the derivative of the second. Putting all together, the derivative is dy over dx equal to square root 2x minus 1 multiply negative cosine 3 minus x plus sine 3 minus x multiply 1 over square root 2x minus 1, and that is the final derivative. Question 1b, y equal to natural logarithm 5x plus 1 over cosine of 2x. Here we have a fraction, so we will use the quotient rule. First, the numerator is natural logarithmic 5x plus 1. To differentiate it, the derivative is 5 over 5x plus 1. Next, the denominator is cosine of 2x. The derivative of the denominator is negative 2 sine 2x. Now, using the quotient rule, the derivative of a quotient is denominator times derivative of numerator minus numerator times derivative of denominator all over the denominator squared. Substituting in our function, we get dy over dx cosine of 2x multiply 5 over 5x plus 1 minus natural logarithmic 5x plus 1 multiply negative 2 sine 2x over cos squared 2x. Finally, we can simplify this a little by combining the negative. Dy over dx equal to 5 cosine 2x over 5x plus 1 cosine squared 2x plus 2 natural logarithmic 5x plus 1 sine 2x over cos squared 2x, and that is our final derivative.
For question 2, we have to find dy dx for 2y natural logarithm for x plus 3x to the power of 7 equals to 2 tangent x minus y minus e exponential x squared by using implicit differentiation. By solving this question, we have to separate the question into 4 parts, which is part A, part B, part C, and part D. Part A is 2y natural logarithm for x equals to 2y 1 over x plus 2 dy over dx natural logarithm for x. Simplifying this question, you will get 2y over x plus 2 natural logarithm for x dy over dx. For part B, you have to differentiate 3x to the power of 7, which you will get 21x to the power of 6. For part C, you have to differentiate 2 tangent x minus y equals to 2 secant squared x minus y times 1 minus dy over dx. Simplifying this question, you will get 2 secant squared x minus y minus 2 secant squared x minus y dy over dx. For part D, you will get e exponential to the power of x squared equals to exponential to the power of x squared times 2x, and you will get 2x exponential to the power of x squared. And for solving this question, you have to write the question back, which is 2y natural logarithm for x plus 3x to the power of 7 equals to 2 tangent x minus y minus exponential to the power of x squared. And you have to write the differentiated questions back into the questions, which I mean is you have to substitute them into the questions. And you will get 2y over x plus 2 natural logarithm for x dy over dx plus 21x to the power of 6 equals to 2 secant squared x minus y minus 2 secant squared x minus y dy over dx minus 2x exponential to the power of x squared. And you have to conclude all the dy over dx to the left hand side and move all the equations that did not have dy over dx to the right hand side. And your equations will be like 2 natural logarithm for x dy over dx plus 2 secant squared x minus y dy over dx equals to 2 secant squared x minus y minus 2x exponential x squared minus 2y over x minus 21x to the power of 6. And you have to pick the dy over dx and move it outside of the bracket, and you will get dy over dx in bracket 2 natural logarithm for x plus 2 secant squared x minus y plus the bracket equals to 2 secant squared x minus y minus 2x exponential x squared minus 2y over x minus 21x to the power of 6. And you have to move 2 natural logarithm for x plus 2 secant squared x minus y, move to the right hand side, and your final answer will be dy over dx equals to 2 secant squared x minus y minus 2x exponential to the power of x squared minus 2y over x minus 21x to the power of 6 over 2 natural logarithm for x plus 2 secant squared x minus y.
So for this question 3, we can see a combination of square root and fraction. So to solve it, we will use only 5 steps. So step 1, we're going to find fx, which means we need to change value inside square root into x for this question. So for the step 2, we're going to use this formula, x equal x new plus delta x. We will search the value of x new and delta x. Remember, the value of x, you can get it from step 1. To find x new is the nearest number of x. Example, 63.98. So we know that 9 is more than 5. So we need to plus 1 the number in front. So it will be 64. So after we know x new, we will find for x delta. So bring the value of x new to in front to get the value of x delta. So for the step 3, we're going to find the value of differentiate of f prime of x. Last but not least, for step 4, we will calculate f x new and f prime of x new. Remember, this step have 2 things to solve, so make sure you do not forget it unless you want to lose your mark. Lastly, for the step 5, we will substitute all the related value we get from step 1 until step 4. So we're going to substitute all the value. You must think, where did I get 3192nd? So that's why I circle it, because if you release it or not, I forget to solve f prime of x new. So make sure before you submit your paper, double check your solution. So I will show you how to calculate f prime of x new. Remember to get your answer correct to 3 decimal place.
Conclusion, the technique of differentiation in calculus play a central role in understanding how functions behave and change. Each method, whether it is the power rule, product and quotient rule, the chain rule, implicit differentiation, or logarithmic differentiation, provide a systematic approach to handling different types of mathematical expression. This technique not only simplifies the process of finding derivative, but also help us break down complex functions into manageable parts. Through differentiation, we are able to determine slope, rate of change, and instantaneous behavior, which are essential in many fields.
Moreover, this technique form the foundation for more advanced concepts in calculus, such as optimization, curvature, and differential equation. They allow us to interpret the real-world situation, model physical systems, and solve practical problems in physics, engineering, biology, economy, and many other disciplines. Overall, the technique of differentiation are not just computation tools, they are powerful methods that depend on our understanding of how quantities vary and interact. Mastery of this technique is therefore essential for study higher mathematics and apply calculus effectively in real-world application.